Okay, let us start with today's session. Today's session is about revisiting unit testing, some exception handling, and logging for debugging. So far, we have what we have seen is we have finished our requirements, and then we learned about argument parsing and things like that. So we are done with our requirement, requirement, and we have also successfully sent mail with all the required details. Now these two sessions, that is the last two sessions, is about the code delivery, the code quality, and how do we insert features into the existing project. So let us get started with unit testing, and we have already seen unit testing before, and we will try to see how unit testing helps in order to test our code automatically whenever there is a new code that is being checked in, or new code that is coming inside the project. Okay, and then exception handling and logging, anyways, we have studied, so we just need to you can take it as a assignment. You can just use those as identify critical parts, and then we just need to put it in except block. Okay, and then instead of printing print statements, we just need to add logging statements, and there are different levels of logging. We just need to add those. Okay, so coming to unit testing. So the unit testing, uh, as we saw, it's about taking one particular area, and then we'll try to simulate that particular area, and then we will verify whether our logic that we have already put in is working or not. Okay, so that is the idea of unit testing. So there are several levels of unit testing. So the first level, sorry, there are several levels of testing in the in the project as such. As we saw, there is unit testing, there is integration testing, there is system level testing, and there is acceptance testing. Okay, so there are different levels. So the first level, that as a developer, that we need to be careful, and we need to be aware about the first level of testing is unit testing. Why it is called as unit testing is because our module is split into several different modules, such as, for example, we have reports, we have our news module, and we have our API module, so which collects data from API module, and there are other modules. So if we look at these modules, these are organized in a certain fashion. That is, a separate folder is given, and then there is a separate file which does only given responsibility. So we are not mixing up the code. So in order to test whether report is working independently without news, we need to kind of simulate this news part and also this API part in order to unit test this. That means without even sending request out to the API, we need to segregate this part as a report, and then we need to take care of the functionalities without even getting into the news and API. Similarly, for API, without even triggering the entire flow, we need to cut that part and test whether that particular part is working fine or not. It's just like when we give car for service. So they check every part, individual part, whether it is working fine, and then they run the car in the ending, and then they verify whether there is any extra vibration, or if there is any clutch or brake problems and things like that. So first thing is to isolate that part. For in our example, we'll just take API, where we are sending API a request, and we're getting a JSON as a response. We will take this, and we will only focus on this, and then we'll make sure that this is working fine, our logic is working fine. So what are the things that we should be thinking before writing any unit tests. So first thing that we need to do is identify the test cases. Identification, okay, because once we identify test cases, then it's easy to write code in order to verify that. For example, in this API case, so there are a few cases. So let us look at the success case. Okay, the success case is, there is this success case. Success case is when I send a request to an API, and API responds with a valid JSON. Okay, JSON. Okay, so there could be failure cases. So what are the failure cases? The failure cases are URL is not good, bad URL. Okay, sometimes URL is good, but the response is not in a right JSON format. So URL is good, but response is bad. So bad can be two things. One is empty response, and one is the unexpected response, such as we are expecting JSON, it could be giving some HTML or something like that. Okay, so this is empty response. So here, if we look at, we have few test cases. So let us try to count them. We have success. This is 1. We have a bad URL. This is 2. We have good URL, but response is empty. We have 3 test cases, 3 tests here, and then there is also response is coming, but that is not in the JSON format. So that is 4th one. Okay. So now we have 4 test cases to deal with this particular API. So in, say for example, actually the work that is being done by that API is only one line, that is requests dot get. Okay, in fact we can get this particular first test case will start working with this, but there are, think about other 3 cases. If we had only a single line of code which is doing that, what would be happening? So if there is a bad URL, the program would stop, and it won't proceed any further. If program is empty, then it will go and stop in the for loop that we are doing. If if it has some other content other than JSON, then again it will give a trace back, or it will crash saying that I'm trying to convert data into JSON, but I got something else, so I'm unable to convert it. So all these bad cases should be handled gracefully, so that the program keeps running and it gives right information to the end user. So if it gets crashed or it stops working, so end user will be wondering what is happening. So maybe he'll just get some generic error, something like server error 500. So he won't know anything. So in at least the developers or the customer team who is handling that particular product should be able to find out what is the problem. So the generic problems, we should not say that okay, server is down or server is not handling that, or it's very vague. So we should be saying that okay, the URL that was sent was bad URL, and in case if the URL is okay, then we should say that okay, response is bad, or I'm unable to parse JSON. We should be quite specific in terms of error handling. Okay, so that is exactly where our unit tests come into picture. So without even running the whole thing in one go, so we don't need to run all of this. We don't need to run any of this. We just need to run this part. Okay, so we saw in the unit test, we'll try to leverage whatever we learned in the unit tests. Okay, so let me just get out of this drawing board. So idea is we simulate news and we simulate API data, but in our example we will only do this. We will simulate API data. Okay, either we can do the actual one, and also we can do both of them. Okay, actual sending the request, and also we can mock that particular. So let us get into code. I've written some code here already. Okay. So this was our module, which is collect data. And collect data, I have just modified its function. Instead of taking an um, uh, empty parameter, I thought it would be easy to test it if I am able to send an URL here. Okay, so I have just put URL as an input. Everything else remains the same, and this is the line of code which sends the request to URL and gets data, and then we are converting data into JSON. Okay, so this is our core code. So let us try to write test cases without even running the whole thing. Okay, so idea is to create in unit tests. We try to test the functionality of that particular function, not the entire flow. In fact, you can use this unit tests to do the entire flow testing. So that is up to developers, that at what level we need to write unit tests, because idea is to cover more test cases, and we have to identify what part of the code has a certain logic and it needs thorough testing. We need to identify that, and then we need to write unit testing. For example, if there are no thorough testing required, so if we are relying on third-party libraries, so we don't need to test those parts, because those parts are already tested and given as a package. But in case if you have any specific logic which you need to test, those parts we need to pick that, and then we need to write test cases first. What are the test cases, what things can go wrong, and then write test cases. Okay, so usually in a module, or in one folder, there will be either you can name this as any file name. So I am just keeping it as tests.py, so that it can be once you see the file name, we know that okay, this is related to tests. Okay, so as we saw in our unit test session, so this was our program. So easy sum, we had simple functionality, and we were testing whether the sum is correct or not. Okay, so that the same program, okay, it's the same program, but we have just modified that. Okay, so basically we are importing the unit test. So let me get it to drawing mode. Okay. So what are we trying to do? First thing is we are importing this. Okay, and then there is a class inside this unit test which is called as test case. So we need to inherit this so that we have a lot of functionalities that is embedded with that particular class. So functionalities are something like it can pick up all the functions, and then it can run them at once, so one by one. So, and then there are test cases which are functions inside those that classes. So this is our we can call this as test suite. So this will inherit from this test case, and then these are the test cases. So this is test case 1, this is test case 2. Okay, so in this part, in the first test case, what we are doing is we are sending an URL which is a valid URL, and we are simply calling the same function that we have written in this collect data. It's the same function. You can see that I have imported that here. Okay. The same function. The same function must be called here because we are trying to verify the logic inside that. So I'm calling that function directly here with the input as a URL, and the expected outcome is I should get a data which I can convert that as a dictionary. Already it is converted as a dictionary inside the function, and expected outcome is if it's a valid URL, and if it's a success case, in that case I need output should be, first thing it should be a dictionary. Second second step is to verify whether the dictionary has elements in that. Sometimes we also might get empty dictionary, which is not good for us. So we should verify whether that particular data that we are getting here, whether it is returning a dictionary, first thing. If it's not a dictionary, so about here, if it's dictionary, verify whether that dictionary is having more than one elements. Okay, so that is what we are doing. So this is one test case. The second test case is our invalid test. We discussed four test cases. So for demo purpose I have written two test cases. So this is from a invalid URL. So this URL is actually invalid. So this URL, when I trigger uh, request for this URL, actually the program would crash if I didn't have try and except block in the collect data here. Okay, so my idea is to verify whether that invalid URL when I send, whether the code is handled correctly. So the idea is to get data. So that is an invalid URL, and in our program we have simply returning an empty dictionary. So first thing I should verify whether it's a dictionary. Yes, it's a dictionary, but it can also be a success case. So it's a dictionary. So this is not sufficient. So I'm also verifying whether the dictionary is an empty dictionary. So when I verify this, that means okay, this for any given invalid URL, I will get an empty dictionary. Okay. So that is the idea in writing test cases. So we have covered two test cases here. We can cover other two test cases. That is given in a URL which is successful, but it is giving some other data which is JSON data, which is not a JSON data, such as maybe it returns an HTML or something like that. So those things can be written in the similar way. So now let us try to run this unit test and let us look at how it looks. Okay. So I'll just come out of this drawing mode. Okay, so this is the command. So whenever you try to run unit tests, we give the -m stands for module. So unit test is a module. It picks up this library, and then it just simply takes. We're just executing this file. That's all. Okay. So just the normal way. So let us try to execute this. In first test case, I'm actually sending a request. In second test case, I'm trying to send a request, but for an invalid URL. Okay. So it says I ran two test cases. I can even make it -v stands for verbose. We have seen that in previous class. Yeah, it's coming already. Okay. When we give -v, it says which test case is being executed. Okay, this is one test case, which is nothing but all the test cases should be having a prefix starting from test underscore. Then it will automatically pick. Okay. In fact, if you do not want to do that, you have to specify which test case you are running. But we don't need to do that. So every test case should have test underscore, and then maybe some your own. When we read the code, the function name should be in such a way that it is understood. So get JSON from invalid URL. That means okay. When we are reading the code, that means we know what exactly that thing is doing. Then it helps us to read the code. Okay. So this is the first test case, and it doesn't pick in an order. It picks in any order because it's just they're just attributes for that particular class. Okay, it doesn't have any order, it can pick from any order. So it is trying to execute for this second test case, and then the first test case, and both are okay. That is because we have handled this. Okay, so that is what is the unit test cases. So now let us try to fail this unit test case. So let us see what it does. So I'm going to just comment this, and instead of doing that, okay, let us put a bug uh, inside the code. So instead of returning dictionary, initializing this to dictionary. So what happens here is I'm just initializing it to empty string, but here it gets a dictionary. So if it's a proper test case, that is if it's a good test case, so this will return this particular data type, which is a dictionary. So in case if it doesn't work, then it won't come here, because we're going to catch the exception here, and then we will return the string. So actually my expectation is it should never return a string, so it should always return a dictionary, either empty or something filled inside that. Okay, so I have a bug here. So let us try to run this. Let me save this. Let me try to run this. So now this is my expectation. So for me, that particular function is like a black box. So I sent from the requirement, it says that okay, this function must be returning a dictionary always. So I have written a test case that whatever is written, I am verifying if it's a dictionary here, and then it is failing at this point because I'm getting a string here. So that is how we are verifying if our logic is fine. So it is possible that some other developer changes this logic and forgets to return a dictionary, and then whenever he tries to check in, automatically there will be some unit testing hooks. So whenever there is a check-in, it automatically runs all the unit test cases in that particular module. So then this will catch the bug before it goes into the repository. So that is how the unit tests are made powerful. So you don't need to do the entire testing just to catch this. Say for example, if we don't have this unit test, what would happen is, okay, the testers would maybe they also forget sending an invalid URL, and this bug can escape until the customer place, and then it is possible that customer is also happy, okay, the things are working. Sometimes it's possible that API guy, whoever has written API, we don't have any control on that. That guy might bring down his website for some reason, or his website is down for some reason, or he wants to change his API or something. There is some change in there. If that thing doesn't work after a couple of months, then it's a big problem. So it's difficult to find out what is the problem. That is because it is coming from the customer. There are a lot of stakeholders involved. Now it starts from the customer. Customer raises a query to tech support guys. Tech support guys raise an escalation to managers. Their managers will escalate to their subordinates, and all the way it comes down to the developers. And developers will see that okay, it's a simple problem, and then say okay, this is we didn't verify using proper test cases. So this is how the bug escapes, and there is a cost attached to that. If it is found here, So the cost is very minimal. That is like maybe that developer is getting, say if he's a junior developer, maybe he's getting um, he's paid some amount. So that amount is what is the uh, cost attached to this particular unit test. But if it escapes to customer, now look at all the people who are involved. So all this time that they spend, so it's actually the multiply their time into their salaries. So it becomes a huge cost of money. At this point, I can, if you just want to take some numbers, it's like here it's only thousands to it takes only thousands, a few thousands to write test cases and build test cases. If it escapes to customers, it may cross lakhs, even crores, who knows. So that is how big this problem can get. Sometimes we have seen that sometimes the problem persists for more than a month, and people are working hard and finally see that okay, this bug is escaped from the development test. So these things always keep happening in the industry, and we should be very careful while writing test cases. We should be taking all the test cases into account. We should be thinking what can go wrong at developer end, and then write the test cases. So here I have two test cases. In fact, you can write two more, and then add more as and when it comes to your mind. Okay, so that is how the critical is about tests. This is about unit tests. Okay, so so how do I verify whether my code is tested? For example, we have written so many lines here. So I want to test whether all the lines are somehow tested. Okay, so in order to do that, so each and every line must be tested. Okay, that means at least in our test cases, our test cases must go and hit all these lines of code, so that there is no line left um, uh, which is untouched by the test case. Okay, so every line must be test. So that is my end goal. So in order to do that, there are several ways to do that. So one of the popular ways is called as coverage, code coverage. So you might have heard about this. Code coverage is nothing but whenever you run certain tests, so it finally the logic, everything gets executed inside the code, and we verify whether that particular module, or whether all the modules are having complete coverage. That means it should at least have it 80 to 90% of coverage. That means 80 to 90% of the lines of the code is covered under the test cases. So let us try to see how the code coverage looks. Okay, so once I run this is just a unit test case running. So there are tools which can do coverage testing. So one of the tools is called as coverage. So you can install that library. It's called coverage. So if you just run so it has capability to run the test cases. So instead of running with Python, I'm just running with the coverage command. So if I run test cases, so it will it ran a complete this one the complete test cases. Now if you want to look at coverage reports, there is another command called as coverage report. Okay. Report. So this coverage report will give all the files which we have tried to hit. Okay, even now it has it is even giving all the library functions, that is it's getting called library files and functions, but we don't require all this. So in fact we can ignore all this in the command line. There is while generating reports, you can ignore all this. Maybe I think it's the command is like this, something like this. We'll only cover the present folder or something. Let me just look at that. Okay, coverage the current di- current directory. Okay. Okay. That's something like source. I'm just trying to eliminate all this for your library files. Mhm. Okay. In fact, these coverages can be exported to HTML. They're nice actually. I'll show you that. Okay, include. Um, First, let me run include only current directories. So by default, it covers all the. There is no data collected. Include all. No. Okay, just let us just forget about that. We'll look at the options later. So that is not our goal. Um, I'll just run it once again. Let me just correct this. Correct the bug that we put. Okay, so that we have proper coverage. Okay, the test cases are fine. Now let us look at coverage report. So let it come. So there are options to exclude and include the files that we want to see in the reports. That anyways you can Google it and find it out. So let us go to our file. So how it looks, what is the coverage? So this is the file name. Okay, so this is our file which we are trying to test. So there are 11 statements and coverage is 100%. That means we have covered all the lines that is present in our module. That means this is a good coverage. Okay, that means my test cases. There are two test cases which have run, and it is successfully covering all the lines. So let me just comment one of the test cases and rerun it. So I'll just rename it to underscore test so that it won't get picked up by the unit test, because it picks only functions which are starting from test underscore. Okay, it ran one test. So let us look at the coverage now. Got the line. Now let us look at this. Okay, so it is telling that there are 11 statements and I have missed 2 statements. That means our second and the coverage is 82%. Now it got reduced to 82%. That is because our test case is doing verifying only the positive test case. So there is negative test case which must have been handled in test case. Now it's not being run. So this particular accept and print block is not getting executed. So these two lines are what is missing um, in our execution. In fact, there are ways to convert this into HTML and things like that. So those things you can explore. But this is the idea. So it gives a nice report. The same report is in HTML, and in fact, you can put this in Jenkins, and then you can also send HTML reports in the mails, and it will give a nice statistics on this kind of things can be done. Okay. So also you can ignore all the files that is not required. So here it's coming, it's showing everything. So those things we can Google it and find out those options. So that's not a problem. So this is how the coverage looks like. So now we can see that. Say for example, a developer has written something and he forgets to write unit test cases, then the coverage would go down from say 90% to 82%. Then we also can raise a flag that okay, the coverage was 90%, now the coverage is reduced. Now the team should make sure that coverage doesn't go down. That is because we are making sure that the test cases are hitting all the lines of the code. Okay, so that is the basic idea of coverage tool. So there are several tools actually. If you're working in DevOps, there are think you might have heard about Sonar, and there in Java there are other tools. So all these things they try to make sure that the code quality is good. So now if I have 100% coverage, that means at least I have the confidence that okay, at least I'm covering all the lines of code which I have written. Okay, so this is about the code quality. So far we have learned about how to stitch things from taking from starting from skeletal code and then dividing into modules. This is one section of our software building activity. And the second thing is to make sure that quality is good. So for that purpose, at the development level, we have to write unit tests and make sure that the coverage is good. Okay, I mean, maybe if your project is very small, you don't need to have coverage. It doesn't matter. But unit test cases are a must, because this will verify our logic at a function level. Okay, so in fact we can call this at a module level as well. That is left to developers, but there should be some kind of automated testing. So this test is now automated, and in fact if you are doing it manually, it might take more than a couple of hours. This just if you have written in unit tests, it will take maybe 30 seconds or 40 seconds. So within that, so you are saving maybe 2 days of time in just 30 and reducing it to 30 seconds. So that is how powerful is automated testing.